Hi, hello, namaskara. Welcome back to Diksha Karnataka once again with yet another mock test solution analysis and discussion. So this is regarding the mock test 2, so the second mock test. The paper is available in the WhatsApp channel and all of you can get that from there. The WhatsApp channel link is given in the description right away. So I urge all of you to join our WhatsApp channel as soon as possible, and you can get all the updates regarding our mock test and further programs that we are doing in Diksha. So that is a very important announcement that I would like to make. And also for those people who would like to get the question paper like as a mail sent to your own mail, so please, there is a registration link also given in the description box. You can go there, you can go to the portal, you can enroll yourself, and then you can receive the question paper onto your mail directly, so that with least distractions, with least kind of social media interaction, you can download the paper, you can attempt it, and then we can have the solution discussion as we have here. So as usual, we are going to do the video in two parts. The first part, we have the first 30 questions, question number 121 to 150. All right, so I would definitely like to know what is your feedback on our mock test series. Please let us know in the comment section, and for further content from our side, we would definitely like your strong support and contribution. So please don't forget to subscribe to our channel and also press the bell icon for timely notification. So let's begin the question. The first question is, planet revolving moving around sun sweeps area A1 in 2 days, A2 in 3 days, and A3 in 6 days. Then the relation between A1, A2, A3 is. So this is from the Kepler's law, and Kepler's law might not be taught in detail in the PU, but this is a very important topic which I would like all of you to make a note of also. So yes, they are given different areas covered in different days, but the Kepler's second law actually states that, so the aerial velocity of a planet or a celestial body revolving around a larger celestial body under gravity, the aerial velocity will remain constant. That means whatever the area they cover in different time period, the aerial velocity is same. For example, like the area covered A1 in time t1, it's equal to the area covered A2 in time t2. It is equal to area covered A3 in time t3. So the rate of area coverage, at the rate at which the area is swept by a planet, is equal at any given interval at any given point. Okay, so that's what. So you have different areas covered in different time, but the rate is always the same. So in this case, t1 t2 value is given. T1 is 2, t2 is 3, and t3 is 6. So let's substitute these values. So we have A1 by 2, A2 by 3, and A3 by 6. So what is the relation between them? Very simple. Just take the LCM and multiply by the LCM, so you can get all the get rid of all the denominators. So the LCM is 6. Multiply by 6, you will get 6 by 2 3A1 is equal to 6 by 3 2A2. 6 by 6 is 1, so A3. So which is that option which matches this exactly? It is option A. Absolutely, option A is the correct answer, right? So this is a very simple question from the gravitation chapter. It's from the Kepler's laws. Kepler's second law is actually coming under action here. It's a very simple question. So please take a note of this particular point, the aerial velocity of a planet being constant. Alright, so if you know that concept and if you know the application part a little bit, it's a very simple question. Alright. And once again, let me remind you about the Abhyas KCET crash course, which is a 28-day long program for all those people who are looking out for cutting through top ranks and top colleges, most privileged colleges in Karnataka through the KCET examination. Please consider this as a very important message from our side. So this Abhyas KCET course, crash course, is available. For further details, please join our WhatsApp channel. So joining our WhatsApp channel is very important for all the updates. You will get it everything over there. So once again, quickly join the WhatsApp channel. The link is given in the description box. All right. Yes. Next question. Now this is from the elasticity chapter. Identical springs of steel and copper. Young's modulus of steel is greater than the Young's modulus of copper. So they are equally stretched. Now the first question is to understand what do you mean by equally stretched. When I say that two objects are equally stretched, that means the load given to them is same. Okay, So they both are given the same load. So they both are stretched with the same force. Alright. So the load is same. That is what. And identical means their length is same, their thickness is same. Identical means they are ditto. Okay. So they both are same dimension wise. And now that they are given with the same load, so then which of the following is true? Now talking about this, first of all, work done, basically work done depends upon Young's modulus and the strain, correct? So because we have only these two to compare, now the Young's modulus, or we even have the force component here, okay? So the load applied, so we can put the load applied as well. One second, just a moment. So even force comes into the picture. So in that case, when the force is given constant, our work done depends upon the strain, okay? Work done depends upon the strain, or that, for that matter, how much it has stretched, okay, the extent to which it has stretched. Now obviously steel has a greater Young's modulus, so, and both steel and copper are given the same load, but steel having a greater Young's modulus, greater elasticity, steel won't respond much to a certain given weight, okay, as much as copper does. So the extension for steel will be lesser than that for the copper. Extension for steel will be less than that for the copper. Copper will have a greater extension because Young's modulus is less. So in that case, very much you can compare these both. The work done in the steel will be lesser than the work done in the copper because the extension is less. Extension for the steel is lesser compared to the copper, therefore the work done to elongate steel is less. So less work done on the steel spring. The correct answer is option B. Okay, the correct answer is option B. So once again, a very simple concept, but only thing is about application. So you have to apply it properly, how to, kind of think and formulate it correctly. All right. Yes. Next question. So look at this question. A solid sphere rotating in free space. If the radius of the sphere is kept increasing, okay, increased, keeping the mass constant. Now the mass is said to be constant, mass is same, and the radius of the sphere increases, then which of the following will not be affected? Once again, this is a straightforward theory question. Conservation. So which quantity will be conserved nevertheless? Mass is kept constant. No matter whatever happens to any other quantity, we all know that the angular momentum of the body will be conserved. So the only quantity in these four options which will remain constant is angular momentum, not angular velocity, not moment of inertia, and not rotational kinetic energy. So these are all very much dependent on the radius of the sphere. So therefore it is not A, C, D, it is exactly angular momentum. Okay, so angular momentum is not going to change. Yes. Okay, so that is the correct answer. It's a very, very simple question. Let's look at the next question. Yes, the next question is, streamline flow is more likely for liquids. Yes, so this is a very important question. Lots of people have a confusion on this. So because you get confused with density, viscosity, surface tension. So all these are pretty similar on the superficial level. So if you look at it, they all might seem like very simple, very related, but they all are nuanced. Okay, they all have very, very distinct understanding. So streamline flow is more likely on, first of all, less density. Okay, first point is they must have low density. The density of the liquid must be very, very less. Okay, so liquids with very less density will have mostly streamline flow, along with one more property, that is high viscosity. The viscosity of the liquids must be high. So when they both are in sync, liquids with low density and high viscosity, okay, density is very less, viscosity is very high, so such materials will have a very good streamline flow. So if you look at any kind of mathematical formula for streamline flow, so they are all emphasized on low density and high viscosity. Such liquids are more suitable for the streamline kind of motion. Even mathematically you can take any kind of formula, Stokes formula or any other formula, and understand. Even Reynolds number also is a great identification for the streamline flow. Okay, so all of that, this fares really very well. So the correct answer is option B. All right, next question. 0.1 meter cube of water at 80 degrees Celsius is mixed with 0.3 meter cube of water at 60 degrees Celsius. The final temperature is, now let me again, this is a calorimetry question, we have discussed it before. So it's again, we have to find a temperature that's coming in the midpoint. So when you add a higher temperature with a lower temperature, they kind of find an equilibrium somewhere in the middle. So you have 0.3 meter cube, okay, volume is given, not mass, is at 60 degrees Celsius. Then you have 0.1 meter cube at 80 degrees Celsius. Okay, so somewhere you have the answer somewhere in the middle. So the temperature that you have to find is somewhere in the middle. Now how do you do this? Same calorimetry principle, heat gained is equal to heat lost. Okay, somebody is gaining heat, somebody is losing heat, so heat gained is equal to heat lost. Okay, so now apply the formula for both the sides. So heat gain, who is gaining heat? So the temperature at 60 degrees Celsius, this portion is gaining heat. So if you have to write as an equation, first of all you have to find the mass, this is the volume. So mass is found out through volume into density. Density, as we know, it is 10 to the power minus 3. All right, 10 to the power minus 3, and hold on a moment. Okay, 10 to the power minus 3 into specific heat of water, okay, into H2O into temperature variation. So T is a larger temperature compared to 60. This we have to equate it to the other part, that is heat lost. So how much is heat lost? Same, the mass from the volume, we get it. It's not minus 3, my mistake. It's plus 3. Okay, density of water is plus 3, 10 to the power 3. All right, into once again specific heat of water into 80 minus T. So equilibrium is lesser than the hot temperature, 80 minus T. So all the equivalent terms will get cancelled. 10 to the power 3, 10 to the power 3 will get cancelled. Ultimately, the temperature comes to 65 degrees Celsius. The correct answer finally is 65 degrees Celsius. So I haven't done the detailed calculation. I give you the chance to do that, and please let me know if there are any contradiction in the final answer in the comment section. Okay, like somewhere the final answer is varying, or we can have a good productive discussion in our comment section. So please do let me know if there is any contradiction regarding the calculation. All right, so when you cancel out all this and you solve for T, ultimately you will get 65 degrees Celsius. All right, this also, if you have a good practice in calorimetry, will be easy. Otherwise it's somewhat a moderate level question. So please practice calorimetry question as much as possible. I have marked these kind of questions important even previously. So please practice a lot of calorimetry questions. All right, let's look at the next question, shall we? Yes, the next question is, the velocity of molecules of a gas at temperature 120 Kelvin is V. What is the velocity? What will be the velocity at 2V? Very simple, you have to relate velocity and temperature, okay, of a gas molecule. So relation between velocity and temperature, all of you know, velocity is directly proportional to root of temperature. Correct? Velocity is directly proportional to root of temperature, root 3 RT by M, all that. Okay, fine. So now we want it in the kind of, we have two different situations. So let's take a ratio format, that's the best. V1 by V2 is equal to root T1 by T2. Now mark all the quantities. Let V be V1, let 120 be T1, and this is V2, and ultimately we want to find T2. Okay, what is the temperature at this velocity? So substitute all the values that we have in front of us. We have V and we have 2V. It is equal to root over 120 divided by T2, which is unknown. We have to find that. So square both the sides, is very simple. V will get cancelled. 1 by 4 is equal to 120 by T2. Just simply cross multiply. T2 is equal to 120 into 4. It is 480 Kelvin. So the correct answer is option C. It's a very, very simple question. I would definitely tag this as an easy question, because only thing that you need to know is the relation between velocity and temperature. All right, so if you know that, you can directly march ahead, and it's a simple ratio kind of simplification. Just take the ratio, cross multiply, you will get the answer. All right, fine. Let's look at the next question. 1 mole of an ideal monoatomic gas is heated at a constant pressure of 1 atmosphere from 0 to 100 degrees Celsius. Then the change in the internal energy is, all right, So once again, what is the change in the internal energy? Change in internal energy, delta U formula. Okay. So how do you find change in the internal energy delta U? So delta U formula is given as N number of moles CV molar specific heat capacity at constant pressure. So change in internal energy happens only at constant volume. So that's why we use CV into delta T. Okay, change in temperature. Now for a monoatomic gas, when we have a monoatomic gas, we know that the molar specific heat capacity CV is equal to 3 by 2 R. Alright, this is for a monoatomic gas and N is also equal to 1. It's 1 mole. So we know that N is equal to 1. So substitute all the given values. Delta U is equal to 1 into 3 by 2 into R value is 8.31 into delta T. So variation, how much is it? 0 to 100. Delta T is equal to 100 degrees Celsius. 100 minus 0, it is 100 degrees Celsius. So you can directly put 100 over here. And if you calculate, ultimately you will get 12.48. 12.48 into 10 to the power 2 joules. Yes, absolutely the correct answer is option C. So you can once again cross check the calculation. So you can let me know if there is any contradiction that you are finding over here. Okay, regarding the final answer, it's very simple. If you just calculate it even directly, you will get the answer. Okay, not at all an issue. Fine. Yes, so this is the correct answer. And once again, if you know this formula, if you are thorough with the thermodynamics as well as the KTG, kinetic theory of gases, if you are thorough with these two chapters, you can easily solve this. Otherwise, it's going to be a difficult chapter. Why? Because mostly students take all these chapters for granted. All the part 2 textbook is mostly taken for granted. Let me remind you students, please don't do that. Thermodynamics is one of the most important chapters. Please practice it as much as possible. Alright, fine. Let us look at the next question. Yes, the particle is executing a simple harmonic motion of amplitude A. Its potential energy is maximum when the displacement from the position of the maximum kinetic energy is. The question is, from a position where the kinetic energy is maximum, how far is that point where potential energy is maximum? Now for this you need to know where is the kinetic energy maximum, where is the potential energy maximum. It's a very simple theory question. Okay, later on you can formulate whatever you need to do according to the question. Where is the kinetic energy maximum? At the main position. Kinetic energy is maximum at the mean position. Where is the potential energy maximum? It is maximum at the ends, at the amplitude. Okay, when the object's displacement reaches the amplitude point, that is where the potential energy is maximum. What is the distance between mean position where kinetic energy is maximum to the position where amplitude potential energy is maximum? What is that position? It is plus or minus A, the amplitude value on either side. Correct answer is the amplitude value, that is plus or minus A. Okay, very simple question. Just need to know where the kinetic energy is maximum, where the potential energy is maximum. If you know this, you can easily crack it. Very simple question, nothing to worry about. Next question. Yes, 3 sound waves of equal amplitude have frequencies. Okay, n-1, n plus 1. They superimpose to give beats. All right, the number of beats produced per second will be. Now it's a very simple logical thing. So you have 3 different sources, 3 different frequencies. Okay, all of this kind of variation, just one. So if you, for example, 500, 499, 501. Okay, so these 3 like this. Just an example. I'm not telling the exact value. Just an example. 3 figures. They are all consecutive. Okay, they are all consecutive. Just one after another. Now you have to take multiple combinations. How many combinations can you take? You can take maximum 3 combinations. Okay, 1, 2, 3, 4, 5, and 6. Okay. So 1 and 2 can be one combination, 2 and 3 can be one combination, 1 and 3 can be one combination, 3 combinations. In this, a very peculiar combination is n-1 and n plus 1. So the first combo, when you write about 3 combinations, the first combo is the n-1 and n plus 1. Now when you add both of the n-1 and n plus 1, what do you get? Basically you get nothing but when you take the average of n-1 and n plus 1, it is n. Average of n-1 and n plus 1 is n. Okay, no doubt. Now this will resonate an existing n. this will resonate with an existing n. Already there is an n, the original n. Okay, there is a wave with n as the frequency. Now n minus 1 and n plus 1 will combine to give n, which will resonate with the actual n. So there won't be any beats because now there is no difference in the frequency. Beats will only happen when there is a difference in frequency. There is no difference in frequency. This will not give any free beats. So there is no beats due to this combo. Okay, no beats. But the other two combos will definitely give. We have n minus 1 and n. This is the second combo, and the third combo is n and n plus 1. Yes, they too have a variation. Okay, they too have a kind of a gap between them. It's the gap of just one frequency. So there are two such frequencies. We have one n minus 1 and n, and there are n and n plus 1. These both will give 1 beats each. Therefore, the total number of beats this combination, these three combinations will give is actually 2. The correct answer over here is 2. So the correct number of beats produced over here is 2. Alright. Yes, so that is the correct answer. Once again, as I told you, it's a logical thing. So just take the combinations and see which of the combinations will work out. Okay. Yes, so that is the thing. Fine. So I hope all of you understood. Not very easy. You have to think a little bit. It's application level question, right? Next question, let's see. Two charges are at a distance d apart. If a copper plate, that's the key. If a copper plate of thickness, okay, copper plate of thickness d by 2 is kept between them, what is the effective force? Now the important thing here is, before even you thinking of the thickness, it's a conductor. Okay, so you have a conducting medium between two charges. What is the dielectric constant of a conductor? For a conductor, the dielectric constant is actually infinity. And when you have a dielectric medium, the force is inversely proportional to the dielectric medium. So force is actually inversely proportional to the dielectric medium. Since the dielectric medium has an infinite constant, okay, dielectric constant is infinity, the force is going to be actually 0. Alright, so you have a kind of a conductor which is kept in between two charges. So that conductor is obviously going to negate any kind of field interaction because it won't allow any field to interact with each other. So that will negate all the field interaction, and therefore there won't be any kind of interaction, there won't be any kind of force. Alright, so the force will be 0. So these are all the things that you have to keep in mind: dielectric constant of conductor and the force and dielectric relation. If you know all these things, it's a very simple question. Alright, it is expected of you to know all these things. It's very crucial part of this chapter. Next question: field due to extremely short dipole as in the dipole length is very less compared to the distance away from it. Okay, in this kind of a special situation, how is the electric field proportional to the distance r, electric field of the dipole? This also is a very straightforward question. Electric field general formula for a dipole at any random point away from it is given as P root 3 cos square theta plus 1 divided by r cube. Okay, this is the general formula. You have other specialized formulas like equatorial, axial formula and all that. But this is general formula where theta is the angle that is joining the reference point, midpoint, okay, and that is the angle between this line and the direction of the moment, dipole moment, okay. So in this case, considering all of the other things as constant, electric field is actually proportional to the, inversely proportional to the cube of the distance. Electric field is actually inversely proportional to cube of the distance. It's a very given answer. If you need to be very much aware of the formula. If you are aware of this formula, you can directly get the answer. E is inversely proportional to r cube. Therefore, the correct answer is option C. Very easy, very straightforward question. There's nothing to think about. Okay, 132. A hollow conducting sphere of radius r has a charge plus q on its surface. What is the electric potential within the sphere at the distance r is equal to r by 3 from the center? Now, read the question once again. What are they asking for? They are asking for electric potential inside the conducting sphere. Now, very crucial information that you are supposed to know once again here is, what is the, how does the electric potential behave, or it is inside a conducting sphere, okay, conducting shell. First of all, the electric field inside is 0. Now electric field is the spatial differentiation of what? Potential. Okay, so electric field can be defined as minus del V divided by, okay, del V divided by del R. So when the electric field is 0, okay, if electric field is 0, that means first of all potential is a constant, okay, inside the inside conductor or conducting shell. Okay, generally inside any conductor electric field is 0, potential is constant. First of all, inside the conductor it's a constant, it is not varying with respect to R. And what is the constant? It is just simply the normal potential formula, which is 1 by 4 pi epsilon naught, whatever is the charge here, that is Q divided by R. That's all, simple. So the surface potential will span throughout the interior. The correct answer is option C. Alright, the correct answer is option C. Very, very simple question. Alright, so inside the conducting shell, electric field is 0, potential is a constant, which is the surfacial potential. Okay, potential is constant, not potential energy, potential. Alright, yet another easy question, very simple. These are all, this electrostatics is very, very important. Please mark any question from this chapter because they're all very important. Every year 5 to 6 questions repeats. Alright, so please mark it very carefully. Next, similar kind of a question from the same chapter. Infinite number of charges, each of charge 1 microcoulomb, are placed on the axis with the coordinates x is equal to 1, 2, 4, 8. Okay, so this is the R value, different R value. So it is R1, this is R2, this is R3, and it goes on. Okay. If the charge 1 coulomb is kept at the origin, what is the net force on the 1 coulomb charge? Okay, on the origin, what is the net force? The net force on the origin is because of R1, R2, R3. Okay, basically it's on the x-axis, so you can put it as x1. Okay, no need if R1 also. x1, x2, x3. Okay. So now, how do you do it? Simple. So you have to take all the components of force one by one and then take it. So in all of them, first of all, 1 by 4 pi epsilon naught will be common. Okay, so net force when you calculate, they are all positively charged, direction is same. Okay, so we can add them simply 1 by 1. Now charge is also same everywhere. It is the charge is 1 microcoulomb and 1 coulomb. Okay, that is the charge combination. 1 into 10 to the power minus 6. Q square, Q1, Q2. This is Q1, Q2. Divided by, now 1 by 1 distance, x1 square, that is 1 square. Plus same combination, 1 into 10 to the power minus 6. x2 square, now it is 2 square. Plus same combination, 10 to the power minus 6. x3 square, 4 square. And it goes on. Now when you take once again the charge common outside, what do you get? So you have 10 to the power 6, 4 pi epsilon naught, okay, into 1 by 1 plus 1 by 2 square is 1 by 4 plus 1 by 16 plus next would be 1 by 8 square, that is 1 by 64. It goes on, infinite series. Now look at the series. It's a very interesting one. 1 by 4, 1 by 16, 1 by 64. It's a geometric progression. Okay, with the common ratio as 1 by 4. Every time when we multiply 1 by 4, we get the next term. So the common ratio is 1 by 4. The starting term is 1. So we have an infinite sum. So for a geometric progression, infinite sum is given as a by a minus r. Okay, for GP, infinite sum is given as S infinity is given as a by a minus r. First term divided by first term minus the common ratio. Now when we apply it here, finally the force is given as 1 by 4 pi epsilon, as you all know, 9 into 10 to the power 9 into 10 to the power minus 6 into the sum 1 by 1 minus 1 by 4. 1 by 4 is the common ratio. So this is 3 by 4. Here in the denominator 4 will go up. 9 into 10 to the power 3 into 4 by 3. So this is 3 and 12. So it is 12,000 Newton. Option B is the correct answer. Alright, yes, it is slightly lengthy, little bit of calculation heavy, not very serious complicated calculation, very simple calculation. Yes, now here the key is you have to identify this as a geometric progression and apply the absolutely the correct formula for the infinite series. If you do all these steps one by one correctly without any fail, okay, without losing your concentration even at a single point, yes, you will absolutely arrive at the correct answer, 12,000. This is not actually a difficult question. This is neither an easy question, so I would definitely put this as a moderate question. So you need to have that particular kind of focus to solve this problem, and yes, requisite knowledge as well. All right, one who hasn't practiced a lot might feel this difficult, so that's why I urge all of you, this chapter is extremely important, please revise it carefully. All right, now let's look at the next question. Yes, a particle A has charge Q and particle B has charge plus 4Q. Okay, so both are positive with each of them having mass m. When allowed to fall from rest through the same potential difference, the ratio of their speed will be very simple. You have to simply equate potential energy, okay, and the kinetic energy. So energy conservation first, so let's do it separately for A. Okay, for the particle A, so we have Q into V, that is the potential energy, equal to half mVA square. Now for B, we have 4Q, okay, 4QV, charge is 4Q into half mVB square. Now it's very simple, we just have to take a ratio. Divide both the equations, of course, half m will get cancelled, QV will get cancelled, 1 by 4 is equal to, okay, 1 by 4 is equal to VA by VB whole square, okay, whole square. Take the root on both the sides, so VA by VB will be, root on the other side is 1 by 2. So the correct answer is option C, 1:2. Okay, so the ratio of the velocity between them is 1:2. Okay, so that is the correct answer. How you do it? Very simple. You just have to have a relation. Okay, you just have to understand how to relate, potential energy and the kinetic energy. So charge basically will have a potential energy. When it is moving, it will have a kinetic energy. So this is how you do it. All right, very simple question. Just you need to know about the conservation of energy idea. All right, next question. Yes, so an equivalent capacitance between A and B. So what is the equivalent capacitance between A and B? No, it's very simple. All the series and parallel, if you know, you will get it very easily. 4 and 4 are in series. Okay, so as you can see, 4 and 4 are in series. So that will be 2 microfarad. In series, they tend to reduce. And it is in parallel with another 4 microfarad. And here 4 and 4 are in series once again, so that will give you again 2 microfarad. So ultimately these three are in parallel. In parallel you can simply add them, 2 plus 4 plus 2, the correct answer is 8. Correct answer is 8 microfarad. Very simple question. So yes, you need to be very, very clear and you have to practice a lot of combination of capacitors, like the series one and parallel. What happens in series, what happens in parallel? In series, they reduce. The same 1 by C1 plus 1 by C2, that formula you have to use. If they are identical, C by number of capacitor. So they are identical, 4 by, there are 2, 4 by 2, 2. Here also 4, identical, there are 2 of them, 4 by 2, 2. And in parallel, it's very simple. You simply add them. Parallel, 2 plus 4 plus 2, it is 8. Alright. So this is how you get the correct answer. Alright. Now let us look at the next question, shall we? Question number 136. A cube of B, side B, has a charge Q at each of its vertices. The electric field at the center of the cube is. Now this is a golden rule all of you have to keep in your mind. For any regular polygon or a tetragon, okay, with a kind of, equally distributed space, symmetric space distribution, like for a cube. Okay, very good example, cube, cuboid and all that. So if identical charges are placed at their corners, then exactly at their geometric center, the net electric field will be 0 because it cancelled out all the identical charges. Yes, option D. Correct answer is option D. So for any regular polygon or like for example square, rectangle, pentagon, hexagon. So any regular polygon or a kind of a tetragon, a three-dimensional structure, equal symmetry and all that. So if you have identical charges at the corners, at the geometric center, the electric field will be zero. It will cancel out. All the identical charges will have same electric field, kind of meeting at equal opposite direction. So they will cancel out because the distance is also same, charge value is also same. They will cancel out. Ultimately, the net electric field at the center will be zero. Okay, it's a very simple question. All of you can know it. All right. Next question. Two small similar metal spheres, A and B, having charges 4q and minus 4q, when placed at a certain distance apart, exert a force F. All right. When another identical uncharged sphere touches C, first touch with A, then B, then remove to infinity. Okay, it touches A, then B, it is removed to infinity. The force of interaction will be, now what will be the new force? Relation with the old force. Listen carefully. So the initial force, let us assume they have same charges, minus 4q and 4q. So we have 4q into minus 4q divided by some d, okay, random distance d. So this is equal to k into 16 minus 16q square k divided by d. Alright, this is the actual force. Now what happens? You have A at 4q, you have B at minus 4q. Now let me bring in another sphere. Okay, C. This is uncharged. Okay, initially there was no charge, so charge is equal to 0. So when they both touch, so they are identical, charge distribution happens as such, they both will end up having same potential. Okay, that means that after some time, after in contact, A will have a new charge, that is the average between 4q and 2, that is 2q. Okay, so this will be the new charge of A. Okay, this is the new charge. Q dash of A is equal to 2q. Now this will gain some charge. Okay, they are sharing the charge, it was uncharged, now it will gain some charge from here. So 2q is remaining, so remaining 2q has gone to C. Now C is coming here and in contact with B, it has a 2q charge. So now how will be the charge? Once again, the final answer will be the average because they are identical. Once again, there will be an average charge finally at both the places. So how you take average? Minus 4q plus 2q divided by 2. Minus 2q by 2. This will have the new charge on B will be minus q. Okay. So for identical spheres of two different charges, when they touch, charge will be shared such that they will have finally same common potential, but the charges will be distributed like as if finally they are having both same charges, that is the average. Okay, they will have the same charge at the end, both of them will have same charge. Now C will also have minus q, B will also have minus q. How? Average of both of them, that is minus q. Now what is the final force? The final force is F dash is given as k into qa dash into qb dash. Okay, so what is qa dash? That is 2q, of course, whole divided by d. 2q into minus q divided by d, which is 2 minus 2q square k divided by d. All right, minus 2q square k divided by d. Fine. Now just look at F dash and F. This is F, this is F dash. Okay, F and F dash. So how do you relate both of them? So this is 16 times, this is 2 times. That means the new force has reduced by 8 times. The new force has reduced by 8 times. Therefore, the correct answer is option B. Alright, this is a repeated question. This kind of question has been asked before. So this is a very important type of question. Please make a note, students. Very, very important type of question. These kind of questions can repeat. So please keep all these small points in mind. So what happens when two conductors touch or objects, charge, uncharged, touch? So if they are identical, charge distribution will be same, both will end up with same charge. And how do you find that? Average. So you can find the average, that is the same charge which both of them will have ultimately. Like first C touched A and the average charge is 2q, both will have 2q at the end. A also 2q, C also 2q. And these both touch. Finally, they will have the common charge, that is the average minus q, and this will also have minus q, gone to infinity, right? Yes, and you can finally find the final force, that is qa, q dash, qa dash, qb dash. So substitute the values and you will get the answer. All right, simple, not simple exactly, is a moderate level question because a lot of things has to be kept in mind one by one. Concept flow shouldn't miss even at a single point, right? Yes, next question, let's see. In the circuit, shows a figure, the current in 4 ohm resistance is 1.2 ampere. What is the potential difference between B and C? That is the question. So 4 ohms, this thing has a current of 1.2. I1 is equal to 1.2 ampere. All right. What is the resistance between VBC? Fine. Yes. So this is the question. So already there is an 8 ohms parallel. Okay. There we have I2 and 2 ohms. So what is the potential here? This is the potential total. We have to find the total potential first. So the total potential of the battery is not given, which is not required as of this moment. Let me tell you why. Because we have I1 is equal to 2 amperes, R1 is equal to 4 amperes, right? So we can find the V1, okay, at exactly at this point, V1 exactly at this across the 4 ohm. V1 can be found out by I by R, that is 1.2, sorry, IR 1.2 into R, V is equal to IR, right? Into 4, which is 4.8 volt. Now the same 4.8 will be there for 8 ohms because they are parallel, okay. Since 4 ohm resistor and 8 ohm resistors are parallel, V2 will also have 4.8 volt, alright, and I2 is equal to V by R 4.8 divided by 8 ohms, okay, 8 ohms. So V by R we will get 0.6 ampere. So now what is the current here? I1 is equal to 1.2. So the total current through the circuit, okay, total current through the circuit is, that is I1 plus I2, I is equal to I1 plus I2, 1.2 plus 0.6, this is 1.8. So since this parallel combination is in series with the BC, this 2 ohm resistor, so the total current will be same for both of them. So even for BC, total current is 1.8, okay. So even for BC, the current is equal to, so VBC can be written as I into R, where I is equal to total current, that is 1.8, and R is equal to 2, because that is actually the resistance between those 2 points. So the correct answer is 3.6 volt. The correct answer is 3.6 volt. Option A is the correct answer. Alright, correct answer is 3.6 volt. Actually, if you know the concept, it's very, very simple. So you just have to do one by one. Okay, this is not a very complicated question if you think straight. Okay, so you shouldn't panic that the battery's voltage is not given. So you are given with one of the current and the resistance. So you can find the potential. They are in parallel. You can find the other potential, other current. Okay, then you can find the total current, and then wherever, if you get the total current, you can find the potential wherever required given the potential drop. Okay, so this is a very simple question if you practice. Once again, current electricity is another very important chapter which you have to practice very thoroughly. All right, students. Yes, let us look at the next question, shall we? Once again, if any contradictions are arising, please let me know. All right, fine. Then when no current is passed through a conductor is a very classical question. It has repeated several times. Most of the students make mistake while reading and understanding the statement. Read and understand one by one. All right. The free electrons do not move. Not at all true. Free electrons are there to move. Okay. So at any temperature above 0 Kelvin, free electrons are moving in some or the other way. So option A is not correct. Fine. Average speed of the free electron is not 0. Okay, average speed is not 0 over a large period of time. So that you can't say actually, because sometimes the speed happens here and there. So that's also is a vague kind of a comment we cannot totally entirely rely upon. Next, average velocity of a free electron over a large period of time is 0. No, that depends on the average displacement. So until then we cannot say that. Okay, so B and C are very vague, very crude. There is no such sustainability in that. But look at option D. Average velocity of the velocities of all the free electron at an instant is non-zero. Okay, that means the average velocity of all the velocities of all the electrons. Okay, so you take velocity of all the electrons at a particular point in time, the average velocity is non-zero, is absolutely correct, because they are in a random motion. If you take over a large period of time, they will nullify to 0, but it is given at an instant, at a particular instant it is non-zero. So that is absolutely correct. The average of the velocities of all the free electrons at an instant is non-zero. So the correct answer is option D. Alright, so you have to think, you have to formulate and then get the answer. Definitely it will be easy then. Otherwise it's going to be a difficult question, even though it's a theory question. Alright, fine. Let us see the next question. A piece of copper and another of germanium are cooled from room temperature to 15 Kelvin. The resistance, it's the common Ohm's law variation. So Ohm's law is not true for every material, and semiconductors are those materials where Ohm's law is not applicable. They are non-ohmic materials. See, general conductors like copper, they are linearly dependent on temperature. Temperature increase, resistance increase. Temperature decrease, resistance will decrease. So for the copper, the temperature will definitely decrease. Okay, sorry, resistance will definitely decrease. So copper decreases, each of them decreases. That is the only decreasing kind of possibility. Increasing is not at all there with the copper. So definitely each of them also can't. So these both options are deleted, 50-50, like Korn-Benedict Karupati, right? Now you are left with only option A and B. Now semiconductors, they are non-ohmic. They don't rely on the Ohm's law or that kind of an explanation on its working. So basically it has an opposite reaction to temperature, like that of the conductor. So conductor has a linear relation, increases, temperature increases, resistance will increase. Temperature decreases, resistance will decrease. For a semiconductor, when the temperature increases, resistance decreases. Okay, when the temperature decreases, resistance increases. This is what happens in a semiconductor. So as the copper increases, for a conductor, decreases. As the temperature decreases, resistance will decrease. For a germanium, resistance will increase. Semiconductor, resistance increase. Semiconductors have a non-ohmic behavior. It behaves opposite to the normal behavior. Alright, so that's the correct answer. That is option B. Look at the next question. A metal wire is subjected to a constant potential difference. When the temperature of the metal wire is increased, the drift velocity increases, decreases, decreases along with thermal velocity. Now one thing is, see, as the temperature increases, thermal velocity, that is the motion, whatever, due to the heat gained, will increase definitely. So that the thermal velocity increases is the correct option. Wherever that is there, that is correct. The others are wrong. So option C and D are to be cancelled, because that's not possible. Temperature increases, thermal velocity increases. But what happens to the drift velocity is the question. Now these both possibilities have increased, decrease. So which is correct? How do you narrow them? First of all, when the temperature increases, it implies that the resistance also increases. For any conductor, just now we have spoken about it, temperature increases, resistance increases. This implies that the current decreases, or for that matter, current density decreases. Now when the current or the current density decrease, they have a linear dependence on drift velocity. Okay, current as well as current density has a linear dependence on drift velocity. So current increases, current density increases with drift velocity is increase. So therefore, when the current and drift velocity decrease, current and current density decreases, drift velocity will also decrease. Option B is the correct answer. Once again, another very simple question, right? So you have to kind of really focus on these first 4 or 5 chapters. electrostatics, current electricity, magnetism, EMI, AC, very highly important. Please focus on them heavily. Right, let us look at the next question. Okay, unit of specific resistance, resistivity. Okay, specific resistance is nothing but a resistivity. Okay, in case you had missed this, please try to recall. Specific resistance resistivity, and its unit is ohm meter. Definitely, ohm meter is the unit. All right, no doubt. Very simple question, very direct question. Next question. A cell of internal resistance R is connected across an external resistance in R. Then the ratio of the terminal voltage to the EMF of the cell is. Now EMF of the cell is simple. EMF of the cell is E. Okay, that's all. But what is terminal voltage? Terminal voltage is given as EMF minus I into R. Now what is I? Current is EMF divided by total resistance R plus NR. So R is common, N plus 1. Okay, R plus NR. So this is the total. Right, so that is R is common, N plus 1. Now we have an R on the numerator, denominator cancel. Just cross multiply, so you have N plus 1 minus 1. So epsilon is constant, N by N plus 1. Terminal velocity is equal to this. So you can cross check the simplification. If at all you are having any contradiction, your answer is contradicting with mine, please let me know in the comment section, but mostly this should be okay. Now you got the terminal velocity, you have the EMF, take the ratio. V by E is equal to, when you divide both of them, EMF will cancel, ultimately what will remain? N by N plus 1. So the correct answer is option C. N by N plus 1 is the correct answer. It's very simple, EMF and terminal voltage. So if you know how to find the terminal voltage, how to find the current, that is the net current, so you can get the answer very easily, right? The correct answer is N by N plus 1, option C. All right, very simple question. Let's see the next question. Yes, two identical wires A and B, each of length L, carry the same current I. Wire A has bent into a circle of radius R. Wire B is bent into form a square of side A. If BA, BB are the values of magnetic field at the center of the circle and the square respectively, what is the ratio of BA and BB? Yes, this is a very kind of, what do you say, calculation heavy. Lot of simplification is required, lot of workout is required. So you need to really focus really very hard, because it's not going to be simple. First of all, you have two wires L. First one, you bent into a circle. Okay, so that circumference is equal to length. R is equal to, 2 pi R is equal to L. 2 pi R is equal to L. L is equal, R is equal to L by 2 pi. Correct. So first you use the normal formula of the circle BA is equal to mu naught I divided by 2R, where if you substitute this, you will get mu naught I divided by 2L, and 2 pi will go up, L by 2 pi, 2 pi will go. Keep it as it is. Okay, keep it as it is. Simplification we can do later. Now the second condition is you are having a square. Okay, definitely side is A. So you know the perimeter is equal to total length, because the entire wire is of L, you are bending it to a square. So perimeter is equal to the length. So directly you can write A is equal to L by 4. That's the relation. You will use it soon. Now what is happening here? You have finite straight conductor, 4 of them. Okay, 4 finite straight conductor. So this is 1, 2, 3, 4. Now how do you find finite straight conductor value? So like this. So you have to take the angle, which is 45, and the formula is like this. So the distance is A by 2. This distance is A by 2. Now the formula is like this. Each of them, okay, each of the side will contribute mu naught I divided by 4 pi into the distance between them, that is A by 2. Okay, into sine of first angle and the second angle. There are two angles, sine of first angle to the second angle. Both are 45. So we have sine 45 plus sine 45. We have 2 sine 45. Sine of angle 1, angle 2. Sine 45 plus sine 45, 2 sine 45. This is because of one side. We have 4 sides. So this is the magnetic field at the center due to the square. Alright. So you can cancel out all the common terms. A is L by 4 when you substitute L by 2, already 2 is there. L by 4 for 8 will go up. So you have BB is equal to mu naught I 2 times sine 45, that is sine 45 is 1 by root 2, 2 into 1 by root 2 is root 2. So you have 8 will go up, 8 root 2 divided by pi is there, L is there. Okay, now take a ratio of both of them. This I assign it to you. Please do this. All of you, please carry out this. Take a ratio between both of them, BA and BB. All the common terms will get cancelled. L will get cancelled. Mu naught will get cancelled. I will get cancelled. Pi will not get cancelled. Here it is numerator. Here it is denominator. They will not get cancelled. They will multiply. Ultimately, you will get the answer as pi square by 8 root 2. These 2 and 2 will get cancelled. So you can check it yourself. Please let me know. Okay, you can check it yourself and please let me know what is happening here. Okay, so the correct answer is obviously pi square by 8 root 2. And if at all you're stumbling somewhere, your your answer is once again contradicting mine. So please let me know in the comment section. All right. So the correct answer is pi square by 8 root 2. All right. Yes, this is the correct answer. Fine. So yes, this is a very calculation heavy question. Lot of steps one by one you have to find out. You cannot squander at even a single point. Otherwise, it's like a house of cards. Like if you falter even at a one level, the entire house of cards will fall down. So please handle such questions very carefully. Such questions are nice, good, so that you have a better practice. You can really gauge yourself. Okay, you can really gauge how far you are set, you are prepared for it. All right, very important. Fine. Yes, let's look at the next question. Okay, next question. Moving coil galvanometer has n number of turns in the coil. Effective area is A. It carries all this. The torque acting on the coil is. It's a very straightforward question. So torque acting on a coil is M cross B, or simply you can write MB sine theta. Okay. Now they are actually perpendicular to each other, so it's okay. The theta can be taken as 90. Now what is M? It is NIA and B. So ultimately the correct answer is option D. Very simple, straightforward answer. If you know the formula, you needn't even do all this derivation. You can directly jump to the answer. So like when you spend a lot of time on the previous kind of question, difficult and very kind of where you have to apply a lot of concentration, these kind of questions will give you some relief if provided you have practiced correctly. You have seen all the questions and you have reviewed them properly, you have revised properly. Definitely you can get there. Otherwise it is going to be a little bit tough. So please focus on these chapters. Let me remind you: electrostatics, current, electricity and magnetism. Very heavy chapters. Please focus on them. Lot of questions. These 3 chapters alone can get you around 15 to 20 questions. Please focus on these questions. Very important. All right. Next question. Let's see. The distance between the wires of an electric mains is 12 centimeter. These wires experience 4 milligram weight force. Okay, so force is milligram. I'll tell you how to find that. The force is milligram weight. The value of the current flowing through each of them will be, first of all, force per unit length is given. So what is the force per unit length formula? Force per unit length formula is actually given as F by L mu naught I square divided by 2 pi r. Alright, where r is the distance between the wires, alright, and I is the current in them, and F by L is the force. So this is given, F by L is given 4 milligram weight. Now any object's force can be experienced in terms of mass weight. Okay, the weight due to its mass. So how do you get that? So mass is given, weight is given. Weight in the sense you have to multiply with the acceleration due to gravity. So 4 milligram weight is actually 4 into 10 to the power minus 6, milligram is 10 to the minus 6 kg into 9.8. This is gram weight or kg weight, whenever you are given force in terms of the weight due to the mass, you have to multiply by 9.8 in order to get the actual force in newtons. Okay, the acceleration and mass, that will give you force. This is force per unit length. Okay, per unit length. So this is F by L. Okay, F by L is given. Okay, now just cross multiply. I is equal to, okay, from here you come here, I is equal to root F by L into 2 pi r divided by mu naught. Okay, so just cross multiply everything, rearrange, you will get this. Okay, when you rearrange this thing, okay, when you rearrange this thing, you will get this. So just substitute all those things. F by L is given 4 into 10 to the power minus 6 into 9.8 into 2 pi and mu naught, they will get cancelled. You will have 2 into 10 to the power minus 7. Okay, and r is equal to 0.12, 12 centimeters, 0.12. When you cancel all of them, ultimately you will get the answer as somewhat 4.85 amperes. Okay, so the correct answer is option A. The correct answer is 4.8 amperes. So you can do the calculation yourself. If at all you are experiencing any contradiction, anything here and there, you're not matching or any mismatch, please let me know in the comment section. There are a lot of questions arriving in the mock test where it is like really like calculation heavy questions. This is very intentional so that if at all you get such number of questions, you shouldn't be kind of feeling misplaced or feeling difficulty. So that's why we are really focusing on you to have a very good or considerable amount of calculation in every question, so that your calculation skills are pretty honed and it's very chiseled. All right, so please consider these questions all very important. All right, let's look at the next question. A ring of radius r made of an insulating material carries a charge q uniformly distributed on it. If the ring rotates about an axis passing through the center and normal to the plane, the normal axis of the ring, with a constant angular speed omega, then the magnitude of the magnetic moment on the ring is. Now let us go through this step by step. First of all, what are they asking? Magnetic moment. Magnetic moment is given as capital M is equal to I into A, right? Simple. And A is nothing but pi r square. Now current is actually not given here, but they are given charge. So how do you find current from charge? That is charge per unit time, but time is also not given here. One thing that is given, it is rotating with an angular frequency omega. So you can write I is equal to charge divided by time period. Okay, current is charge per unit time, this time period of rotation. Time period is nothing but 2 pi by omega. 2 pi by omega, omega will go up. Yes. So this is the current. Charge into omega by 2 pi. So we can substitute over here. So we will have M is equal to Q omega by 2 pi into pi r square. Definitely pi will get cancelled. You have half Q omega r square. So this is the magnetic moment of a rotating coil. Half Q. Yes. Option B is the apt answer. Okay. So yes, this is how you do it step by step, as I told you. So such questions shouldn't make you frantic. Just think. Okay. Just sit, relax and think. Starting from what you know. Magnetic moment, all of you know, it's very simple. Current into area, and then current is charge per unit time, where time is the time period of the rotation, and then a time period is definitely 2 pi by omega, 2 pi by angular frequency, right? So when you substitute over here in like I and over in place of magnetic moment, common terms will get cancelled. Ultimately you have half Q omega r square. All right, very simple question if you know the concept and if you are pretty much relaxed enough. Otherwise there are chances that you are going to make mistake or going to jump into a wrong answer. Okay, so this is not a very easy question, somewhat a mediocre level, okay, of difficulty. So please focus on this question once again. Let me remind you those 3 chapters. All right, electrostatics, current, electricity, magnetism, very huge chapters playing a crucial role in the CET examination. Please make these chapters very clear. 1/3 of your CET exam. 20 questions out of 60 is set. Okay, so please focus on these chapters mainly. Next question, let's have a look at it. Next question is, the horizontal component of the Earth's magnetic field is 3.6 10 to the power minus 5, where the dip angle is 60 degree. The magnitude of the Earth's magnetic field is, see, in fact, in the official syllabus that is given for the PUC, Earth's magnetism is actually removed from the PUC syllabus. So its relevance in the CET is actually questionable at the moment, but still it's a very simple and interesting topic. So let's have a look at it. Now they have given the horizontal field. Horizontal field is actually related to the actual field like this, where theta is the angle of dip. Okay. Now we have the angle of dip as well as the horizontal component. Let's substitute them. So 3.6 into 10 to the power minus 5 is equal to actual magnetic field into cos 60. Now cos 60 is 1 by 2. Okay. B by 2 is 3.6 into 10 to the power minus 5, right? You just have to cross multiply. B is equal to 2 into 7.2 10 to the power minus 5 Tesla. So the correct answer is option B. Option C is the correct answer. Okay. 7.2 into 10 to the power minus 5 Tesla. All right. Yes, very simple. I told you this, this type of questions from this topic of Earth's magnetism is very simple. It's very doable. Okay, very interesting as well. So there is no harm in knowing this. If at all a question pops out of nowhere, so you will be able to do it very easily, right? Very simple question. Look at the next question. A deuteron of kinetic energy 50 kilo electron volt is describing a circular orbit of radius 0.5 meter in a plane perpendicular to the magnetic field. Kinetic energy of the proton that describes a circular orbit of the same radius. They have the same radius. Now what will be the kinetic energy of a proton if deuteron has this much kinetic energy? Now kinetic energy is half mv square, all of you know, but in terms of a charged particle moving through a circular path in a magnetic field, that kinetic energy is given as b square q square r square by 2m. If you hadn't had any idea of this formula, please make a note. Kinetic energy of a charged particle moving in circular path in a magnetic field. Okay, that will have a kinetic energy of b square q square r square by 2m. Now here the numerator is very much fixed. Okay, numerator is very fixed. Why? Because magnetic field is the same, radius is the same, and both have the same charge. Deuteron and proton has the same charge. They have only one single electron, sorry, single proton, my mistake, single proton. But where does the variation occur? The variation occurs in the mass. So kinetic energy is actually inversely proportional to mass. That means that the energy of the deuteron and energy of the proton, if you take a ratio, the mass ratio will be in the opposite order because it's inversely proportional. It's mass of the proton divided by mass of the deuteron. Okay. Now what happens? Look at this. Energy of deuteron is 50 kilo electron volt divided by proton energy, we don't know. Now mass of proton by mass of deuteron. Mass of proton is related to be same. Deuteron mass will be 2 times mass of proton approximately. Why? Because see, deuteron has one proton, one neutron. Okay, and let's assume that the mass of the proton and the neutron are same. Let's assume they're pretty close. In that case, the mass of the deuteron is 2 times the mass of proton. So in that case, this is mass of proton, this is 2 mp, mp will get cancelled, 1 by 2. So this implies that the energy of the proton is actually 50 into 200 kilo electron volt. Okay, kilo electron volt, that is option D is the correct answer. Alright, once again a very simple topic, but yes, everything relies on the knowledge of this formula. So if you know that, or if you can get to that somehow, definitely you can get this kinetic energy inversely proportional to mass and compare their mass and ultimately find the answer. Alright, so this is a very important question. Please make a note of this question, students. Alright, from the magnetism chapter, very important. All this kinetic energy, radius, velocity, these are extremely important. Please make a note. All right, fine. So now let us go to the last question of this part, that is the 150th question. Susceptibility is positive and large for paramagnet. So what happens here is that susceptibility is positive and large for which kind of material? Very simple. Susceptibility is often represented using chi. Okay. So where is the chi positive and very large? Obviously the correct answer is ferromagnetic substances, not dia, and neither it is para. So for dia it is negative, for para it is a very small value even though it's positive. Positive and large is definitely for ferromagnetic material. Okay, so correct answer is ferromagnetic substances. Very simple question, direct theory based question. So if you know the properties of ferromagnetic, diamagnetic, you can very well do this. Okay, right? So this is the penultimate question. Let me remind you students, if at all you have any contradictions, anything that you would like to communicate to us, definitely make good use of the comment section, so we can have a very kind of productive discussion over there. I highly recommend that, I highly encourage that. Please let us know any feedback of all the videos, that all the content that we are trying to do. If at all you have anything more to let us know, or any specific needs you have, please let us know that. All right, so ultimately I would really like you to share this video with all those people who are in need of our this kind of a content, who are looking forward to very genuine kind of a content to practice, to gauge themselves, to know what is their level with respect to CET, with respect to other competitive examinations. Please share it with all of them. And if you like this video, please press the like button right away, and help us provide you more and more content. So subscribe to our channel and press the bell icon, so that you can right away get the notifications, timely notifications, that what kind of content is released when. So it will be a huge help to a lot of people, and let us also cooperate with us, so that we can produce genuine content for all of you. And let's have a total motivation for all those people who are truly studying for KCET and for other competitive examination, and aspiring to have a very good life ahead. So until the next time we meet, this is Karthik signing off. Adios.